Okay, so today we're starting a new unit in financial math. Hopefully you'll enjoy this unit. It's usually students find it to be more applicable to uh, things that they're going to use in the future. So here are the topics that we're going to cover: simple interest, compound interest, annuities and sinking funds, and amortized loans. Today we're going to talk about simple interest and compound interest. So let's start with simple interest. Simple interest is just a fixed percent of your principal. So with simple interest, we actually have a formula for the interest. I equals PRT. Perhaps you've seen this before. P is your principal, the amount that you've invested. R is the rate in decimal form, and T is time in years. You can also find the amount in your account after the given time by just adding the principal to your interest. Okay, and so if you follow that out, we can factor the P and we get this formula on the right. A equals P times the quantity 1 plus RT. Okay, we could ask 4 questions with simple interest. How much money will be in the account after T years? That's asking you to solve for A. How much should you invest for T years if you want a specific amount after that amount of time? That's asking you to solve for P. What interest rate will give you the amount A after T years? That's asking you to solve for R. And then how long will it take for the account to rise to a certain amount A? That's asking you to solve for T. So we can solve for each of those 4 variables that were in the equation. Let's look at a couple examples. Suppose you invest $2,000 in an account that earns an interest rate of 1.5% per year. How much money will be in the account after 5 years? Oops, that shows you everything. All right, so we're going to start by listing off what we know. So we know principal, right? You invest 2,000, so that's your P. We know the rate is 1.5%. You need to convert that to decimal form. That means move the decimal 2 places to the left. So you get 0.015. And you know that the time is 5 years. Okay, that leaves us with A to solve for. You can either solve it in the equation A equals P times 1 plus RT, or you can solve for I first and then add it to P. And so that's what I've done here in the notes. So I equals principal times rate times time. So 2,000 times 0.015 times 5 is 150. So that's the interest that you would gain after 5 years. And so if we add that to the principal, that leaves you with $2,150 in the account after 5 years. You try how much will be in the account after 8 years. Let's try another one. Tanner wants to have $3,000 in 5 years to help pay for his college education. If he invests in an account earning a simple interest rate of 5% per year, how much should he invest? So what is this question asking you to solve for? Well, it wants to know how much he should invest, so that's P, right? We want to know what's P. And we've got some information here. He wants to have $3,000, that's his A, in 5 years, so there's T. And the only thing missing is R, and here it is. R is 5%. So in decimal form, our rate is 0.05. Okay? And it's simple interest. So we're going to plug into the formula. All right, so we just plug everything in. We need to solve for P. So first I added this stuff on the right. So you just type that into your calculator and you get 1.25. And to solve for P, we divide by 1.25. So the principal was $2,400. So Tanner should invest $2,400. All right, let's look at Kelsey's example. Kelsey invested $200 in a bank account earning simple interest. After 3 years, her account had $255. What was the interest rate? So here we have our principal is $200. Time is 3 years. The amount is $255 that she ends up with, and we want to solve for R. So we plug into the simple interest formula. Now we need to solve for R. So as a first step, let's divide by 200. Okay, we want to get r by itself, so our next step should be to subtract 1. And finally, we need to divide by 3. Now, if I do this all at once in my calculator, that'll give me the most accurate answer. If I divide up here at the start and get a decimal, that's going to round things a little bit. So you want to avoid rounding as much as possible. Wait till the end and just plug this whole thing into your calculator. Make sure you can do that on your own. Okay, so what do you get? 0.0917 is what I get. So when we give our answer for the rate, we should always convert back to a percent. That means I need to move the decimal 2 places to the right. So the rate was 9.17. Okay, so that's simple interest. What about compound interest? Compound interest is interest that is paid on principal plus previously earned interest. So your interest is compounding. Every time you earn interest, every compounding period, you get to earn interest on your interest. We can compound in different amounts of time. We could compound annually. That means that your interest is added every year. We could compound quarterly. That means your interest is added every 3 months. We can also talk about interest compounded semi-annually. That's twice a year. Daily, monthly, that's 12 times a year, or continuously. Okay, so let's look at how this would work. Suppose that we invest $3,000 into a bank for 3 years that pays 10% annual interest compounded annually. How much will be in the account at the end of 3 years? Well, at the end of the first year, we get interest, right? So at the end of the first year, let's plug into the simple interest. A equals P times 1 plus RT. Where here, my principal was $3,000. My rate was 10%, so 0.10, and my time has been a year. So I'm going to put a 1 here. And that gives me $3,300. Okay, now at the next compounding period, I get to earn interest on that extra 300. So I'm going to use the 3,300 as my principal. So now the amount in the account will be 3,300 times 1 plus 0.10 times 1. Again, it's been 1 more year. Okay, and that's going to give you what? $3,630. And I could do this again. So in the third year, that $3,630 is going to be my principal. So here's the table. So after 3 years, there will be $39.93 in the account. Now, what if you had just invested that into an account earning 10% interest of simple interest? Well, then we would just plug into the simple interest formula with now our time is 3, and you can see we would have $3,900. So having that compound interest got you an extra $93. All right, now in practice, you don't want to have to compute how much you have in the account every compounding period. So there's a formula for that, and here it is. So again, A stands for the amount in the account, P is your principal, R is the rate, and M is the new variable here. M stands for the number of times that it compounds per year. So with annually, M is 1. With semi-annually, M is 2. With quarterly, M is 4. With monthly, M is 12, and so on. All right, so let's look at a couple examples. Again, we can ask the same 4 questions. We're going to save question number 4 for a little bit later. That's going to require us to use some logarithms. All right, so let's start with this one. Suppose we invest $1,000 into an account paying 4% interest per year, compounded quarterly. How much will be in the account after 10 years with no withdrawals, and how much interest is earned over the 10-year period? Okay, so let's pick out what we know. The principal is $1,000. $1,000 is invested. The rate is 4%, which is 0.04. M is 4. That comes from compounded quarterly. And T is 10 after 10 years. From here, we just plug into the formula. The amount equals 1,000 times 1 plus 0.04 over 4 to the 40. Now, you should try plugging this into your calculator and make sure that you can get the right answer. So we get 1488.86 after 10 years. Now, how much of that is interest? Unlike with simple interest, we don't have a separate formula for interest, but your interest is always just your amount minus your principal. So if I invested $1,000 to begin with, and I ended up with 1488.86, what was my interest? Well, it's just the difference. So 488.86. Let's look at another example. Trenton wants to invest $10,000 in an account earning interest compounded quarterly. That's 4 times a year. If at the end of 6 years he has $11,500 in the account, what interest rate did the account have? Now these, I think, are some of the more challenging questions in the compound interest. Here we need to solve for R, right? We don't know the rate. And remember, R was in those parentheses, which had an exponent outside. So we have to be able to get rid of that exponent. So let's start by identifying what we know. We're going to show you a bit more than that. All right, so principal is $10,000. Trenton invested $10,000. We don't know the rate. The time is 6 at the end of 6 years. Our amount is $11,500, and M is 4. Again, it compounds quarterly. Okay, so M is 4. We want to solve for R in the equation for compound interest. So remember, our goal is to find this R. That means that I need to get to the R. So the first thing in the way is the 10,000. How do I get rid of a multiplication? I divide. So I'm going to divide both sides by 10,000. On the right, it just cancels, and on the left, we've got 11,500 divided by 10,000. All right, now to get to the R, the next thing in my way is this exponent, 24. Well, how would you undo if it was squared? You would take a square root, right? Or take it to the 1/2 power. So that's what we're going to do here. So let's take it to the 1/24 power. So I'm going to take both sides to the power 1/24. Now you can see here 1/24 times 24 is just 24/24, which is just 1. So that eliminates my exponent on the right side. All right, so here's what we have, and now I can drop the parentheses if I want. My next step is to get rid of the 1. I undo that by subtracting. So let's subtract 1 from both sides. And my last step to isolate the R is to multiply both sides by 4. All right, again, this is something that you can type into your calculator. Take a second, pause the video, and type this into your calculator. Make sure that you get the same answer that I get. In fact, I'll pause with you for a second. Make sure that you're putting parentheses in the right spot. All right, what did you get? 0.0234. And again, this is the rate, so let's convert it to a percent. So move the decimal 2 places to the right. He invested approximately in an account earning approximately 2.34% interest. All right, there's one more kind of compounded account, and that's interest that's compounded continuously. And for that, the formula is A equals PE to the RT. Sometimes we'll say A equals PERT. All right, and this E is just the E that's on your calculator above the LN button. It's on the left side of your calculator, third one down if you're using the suggested calculator. All right, so let's just look at one example with this. Joe has $25,000 to invest for 10 years. He's considering two accounts. The first has a simple interest rate of 2.5%. The second has an interest rate of 2.3% compounded continuously. Which one would be the better choice? Now, you can't just look at the rates because the way that the interest is compounded could affect how much he'll have at the end. So we need to think about how much he'll have in both accounts after 10 years. So let's start with account 1. Oops. So account 1 is a simple interest rate, so we're going to use A equals P times 1 plus RT. And what do we know here? We know that P is 10,000. Oh, nope, sorry. What is P? P is 25,000. The rate is 2.5%, so 0.025, and time is 10 years. Okay, so plugging in, I get A equals 25,000 times 1 plus 0.025 times 10. What does that give you? I get 31,250. What about account 2? Well, account 2 has an interest rate of 2.3% compounded continuously. That means I need to use the PERT. So A equals PE to the RT. Where here, the only thing that's changed is my rate is now 0.2023. And time is still 10 years, and my principal is still 25,000. So A equals 25,000 times E to the 0.023 times 10. Okay, you should be able to plug this whole thing into your calculator. And I get 31,465.00. Which one's the better account? Account 2 is better. It has the better return over 10 years. Okay. All right, so here's a summary of the formulas that we've used. Simple interest, compounded M times per year, and compound interest compounded continuously. We'll talk more about these on Wednesday. Give the problems on the worksheet a try, and we'll talk about those on Wednesday, and I'll collect them in class.